I'm Anil Kumar. Welcome to my YouTube channel and the website globalmathinstitute.com. In this video, we have a question based on circle. This is examination style question which is normally seen in many test papers. If you want to learn from me, you can always send an email on the address given here. Now let's have a look at the question itself. A circle C has equation x square plus y square minus 20x minus 24y plus 195 equals to 0. Now, based on this standard form of circle equation, we have four questions for you. The very first one is to find the center Q of the circle. B. Find the radius to the circle C. So that is the circle C, and we need to find the radius of this circle. Find length of the segment from external point A, which is 2532, to the center Q. And part D is find length of the tangent from external point A, 2532, to the circle. You can pause the video, answer the question, and then look into my suggestions. So let's think, how can we solve this particular equation? Now we need to work with the given equation, which is x square plus y square minus 20x minus 24y plus 195 equals to 0. Now some of you who are experts in working with the standard form of circle equation can very easily answer all these questions. But many of my students have not really done circle in standard form to that extent, and so they might use completing the square method to find the center of the circle, correct? So that is one thing. And those who know the trick, what they will do is they will find the value of Q from these. And as you know, the center Q will in that case be how much? Well, it is half with change sign. So half of 20 is 10 and sign reverses to plus. And this is again minus. So it becomes plus and half of 24 is 12. So that is how they can get the center point Q of the circle. Perfect. You can also find the radius from here, right? So the radius of the circle also they can find, and the value of the radius will be 10 square plus 12 square minus 195 square root. So if you know the formula, you can easily solve this question by knowing the formula. And so you get the radius, and then you can do part C and D also. But now we'll look into the other method, which is the um, completing the squares. To find radius, I should say to find the center, correct? And then the radius, right? So we'll do the completing the squares method. So let me call this as our alternate method, correct? Now, this is the method which is normally used in most part of the world. Okay, so let's look into what this completing the squares method is and how can we solve this particular question based on completing the squares method. So here is a figure for you. So we do have a circle. We need to find the center Q. We are given an external point A and tangential point P. right? So this external point is given to us as 2532. Right. Let us first see how do we use completing the squares method to find the center of the circle. So we are given the equation which is x squared plus y squared minus 20x minus 24y plus 195 equals to 0. Let's collect the x terms, which is x squared minus 20x. Now, to make it a perfect square, I need to add and subtract half of 20, right? I need to add and subtract half of 20. So let me do that. So we'll add half of 20 square, right? So 10 square, and we'll subtract 10 square. Now adding and subtracting the same number doesn't really change anything, okay? But it makes a huge difference, since now if you look into these three terms, they can be written as what? They can be written as x minus 10 whole square. Minus because this is minus 2ab. Do you see that part? So that is how we complete the squares. To complete the square, I needed 10 squares. So we added and subtracted 10 square. Now, let's look into the y terms. So the y terms for us are y squared minus 24y. Now, what will you do to complete the squares for y? Well, of course, half of 24 is 12. So we'll add and subtract 12 square. You get the idea. We'll add and subtract 12 square, and then we can complete this square also, correct? So we get here plus y minus, because this sign is minus, 12 whole square. Now by adding and subtracting these numbers, as you can see, we do have minus 10 square. So let me write that as minus 100, and minus 12 square, which is minus 144, correct? And we already have plus 195 equals to 0. So that is now our equation. Is that correct? Now you can always rearrange this equation, and you get x minus 10 whole square plus y minus 12 whole square, taking all these terms to the right side, which gives us 100 plus 144 minus 195. So now here we get both the values, one of the center and the other for the radius, right? X square plus y square equals to r square, and this is translated to 10 and 12. So the center Q of the circle now is at 10 and 12. Is that clear to you? And the radius is equal to the square root of the right hand side. So I'm writing it purposely in this fashion so that you can understand that the formula which I used earlier makes sense, correct? So that becomes the radius. You get the idea. So we'll see how the earlier standard form equation formula and the points come together, right? So as you can see from here, so it is for the benefit of those who are not using the standard form of the equation effectively. So for them, you can now see that this equation, the standard form, could be written as x squared plus y squared plus 2 fx plus 2 gy plus some constant, right? So let's say k equals to 0. So clearly from here, the center is where? So the center, as you can see, is at half of f, right? With a negative sign. That becomes the x value, and half of g with a negative sign, and the radius r is equal to square root of f square plus g square minus k square root. You get the idea. So we get this formula directly from the standard form, and that is a standard way of doing also. Okay, so we got our answers for part A and B. Now, can you tell me how are we going to do C and D? Well, C is find the length of the segment from the external point A to the center. Well, we know these 2 points and we can use the distance formula, right? So we can use the distance formula and we know what is distance formula, correct? So distance formula is square root of what? Change in x values, let me write like this, plus change in y values. Is that clear to you? And square root. So that is the distance formula which we will use. We know the center point Q and the exterior point 25, 32. Perfect. Okay. So here is our neat solution which I typed out. As we discussed just now, we need to do complete the squares to find the circle if we do not understand the standard form equation inside out. Well, the way is we do half of this and square it, which is 10. So we add 10 square and subtract 10 square. That completes the square for the x, and for y it is minus 24. So half of 24 is 12. So we added and subtracted 12 square. So that helped us to make y minus 12 whole square. Now the terms on the left will be now taken to the right side, and we get here 100 plus 144 minus 195 as 49, and that gives you the square root of 49 as 7. That becomes the radius, correct? So you now know that this is a circle with center 10, 12, and the radius of 7, which is basically square root of 49, right? So square root of 49 is 7, and that is how we get the value of r. Is that clear to you? So now we know the value of r, we know the center point q, which is 10, 12. So let me write down here. And we know the value of a, which is given to us as 25, 32. Now you also now know what the formula is for directly finding the center and the radius from a given standard form of the circle. So make a note of this particular formula, which is x squared plus y squared plus 2fx plus 2gx plus k equals to 0. The center will be half of the coefficient of x, which is f, right? So with a negative sign. So negative f negative g, and the radius will be square root of f square plus g square minus the constant, as you can clearly see here in the calculations done. Is that clear to you? So we have done part A and B. Now let's think about how are we going to solve for C, which is find the length of the segment from the external point to the center. Well, that should be simple. We know the distance formula. So we write distance is equal to square root of the x value difference between the two, which is 25 minus 10 whole square, plus the y value difference, which is 32 minus 12 whole square. And when you do square root, you get the distance PQ, correct? So that gives you the value of PQ. Is that clear to you? So we now know the value of PQ. You can use the calculator and find the answer. Perfect. Now, here are the calculations for the value of PQ. So what we have done here is substituted the values in the formula itself. Okay, so the formula is x2 minus x1 whole square plus y2 minus y1 whole square. Substituting the coordinate points, we know the a value is given to us external point 25, 32. The center we found 10, 12. And so 25 minus 10 whole square plus 32 minus 12 whole square within square root gives us a value of 25. So we know now that this length PQ is 25. So we've done part C, which is to find the length of the segment from the external point to the center. Now part D is find the length of the tangent from the external point. That should not be difficult. We know tangent with the radius will form 90 degrees. And so we have a right triangle, correct? So we are now working on a right triangle. We can apply the Pythagorean theorem to find PA, right? So PA will be difference of squares between 25 and radius square root. Is that clear to you, right? So we can say PA whole square is equal to QA whole square minus R square. So we can now substitute those values and find the distance from A, or length of the tangent, you can say, right? So the length of the tangent as required in this particular case will be AC square minus, sorry, it's not AC, but typing error, AQ square minus R square, which is 25 square minus 7 square, and that gives you the value of 24. So the numbers are so taken so that we have very easy calculations, right? So this question can also come for IB students as without calculator question, right? So it could be IB challenge without calculator, right? So that could be the case. So remember, here is again, in short, the formula which we have used to find the direct answer. It really helps to remember this particular formula. And you have also understood the method of completing the squares to find the solution. I hope the concept is absolutely clear. This type of question is frequently seen in examination test questions. So, working with this and practicing similar will definitely help. I hope you find this video interesting and useful. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that would be great. Thanks for your time and all the best.